Hello everyone and welcome to Geonodes Challenge series where I dig deeper into the potential of geometry nodes to show you what amazing things you can achieve with this procedural modeling and animation tool. This is the final part of this project of hologram planet map project, and this is where it all happens, where everything is made to look awesome. So we will be looking at all the cool stuff that are packed into the shader. If you want to see the geometry nodes, you can check out the slide at the beginning to see what each of the other 5 parts contain, and you can look at the link in the description to jump to the part that you find more interesting, or start from the part 1. It's up to you. In this video, we will be looking, like I said, at the hologram shader with everything it's inside of it, including the planets, the continents, that are built inside the shader. That's cool contour of the continents, the glowing on the outside, the transparency, everything that you see there. Also the emission shaders that were used for the tracers and the particle systems, and the world shader that also is connecting to the reveal effect. As you could see at the beginning, the scene starts dark and then it's been lightened up, because everything is happening here and you basically don't have anything. If we switch to solid view, this is all the geometry in our scene. Without it, you have nothing. So basically, what you see in the background, it's in the world shader. So let's start with the hologram shader of the planet. This is really cool. It's here, and we will be looking first at this stuff that you see here, the red dots, and as you could see in the animation, and you can see here, if we play a little bit, some of them turn blue when the tracer starts to move. Here, as you can see, let's find one that it's just living now. Okay, this is the frame. As you can see, we have this, we start, and then we get this, and then this is fading, and the other one, the red one, is growing. This is all done here. Like I showed you in the third part of this series, we transferred basically the information about the starting point, the ending point, and about this animation here, the tracer, and everything was used here. So if we look here, we see the attributes that come from the geometry nodes, the starting point, the fade over time effect here, and in the other frame you get the ending point and fade over time for the ending point. And the way this works, we chose a mate color. So if we look at this, Control Shift click with the node wrangler, this is our mate color. We have a white color that is basically added here with everything. But let's see how this is built. We have these input points. Let's look at them. And then we pass them through a color ramp to give them this shape. And then this data is used as a factor to mix between two things. The color of the points is the blue color here, And the other thing is the mate that we use, the white color. You will see later on why. For the fade over time effect, we used this data, and we created this hologram that you see here with these stops. As you can see, I'm gonna go one by one so you can see the values. And that gives us this result that you see here, that is used as a factor for this mix node, giving us this result. We basically mix this color with this mate white, using this as a mask, fade over time, and then we can use this result to mix them for the color here, where we again add on top of everything, we add the mate color, this one here, and we use as a factor this to make sure that we restrict this effect to this range here. So we basically get this result here. So these dots will grow and fade as this tracer goes away, basically. And we use this information to control the colors of everything in one part, and in the other part to control the strength of the emission shader. Here we get this. As you can see, this is also fading over time, as you can see here, because of this color ramp here that controls the values. So what did we do with these values? We created first a mask, point of contact, that it's basically adding what happens with the start points with what happens on the end points, that are built similarly. We start with the end points and we pass them through a color ramp to get the radius, and then we use this color ramp here. Let me go to it to see the values, and that's giving us the fade over time effect. Then we mix with this red color from here, and by mixing them using the same mate color and this as a factor, we get this result. And then using this as a range retainer, we get this result. It's basically restraining the effect of everything we see here to this range here. And then again, we use this fade over time color to make this fade over time based on the position of the tracers. Again, all about that in the previous videos. So once we combine this, we got this result. So we got a mask between 0 and 1 from black to white that decides just how much strength we want to give to the glow shader. We have this glow control here. We will come back to this one because it's also adding information about the continents, but this is for the points of impact. We have this strength here that we can control from here for the shader, the emission shader. And the color of the emission shader is given by, like I said, what we have here, these controls. So we have the points of impact colors, start point and end point combined here. And then we add the color of the planet and the color of the continents and everything. And here we have something that adds the color of the oceans and stuff like that. Everything mixed into this shader. But let's go to the continents, and then things will get will have much more sense. Of course, we need a texture coordinate, and that's what I chose, object. And because the planet is rotating and we are not using the UV map, we have to have a procedural way to get the rotation information from the geometry nodes. And what I did, if we look at the module that it's controlling the rotation speed, meaning this one, the rotation of the planet, I took this value, the output of this node, and I pass it here to the group output. In the group output, if you go, you have this rotation speed. It has this name, but not this is not the important one. The important one is here. For this rotation speed, we need this value from here. And this value, once we pass it here, we get access to that vector here that we can use to rotate the coordinates while the planet is rotating. Important thing is to change this from point, the default, to texture. Otherwise, continents will rotate the opposite direction as the planet, and you will basically lose the sync with all these lines and all this data. You're gonna look weird. But once you do this mapping, you can use this mask grip texture to get the shape of the continents, as you can see here. And the way the contour was built was by taking a crunched version of this texture with another one that is inverted like this. And basically you have this texture and this inverted version of this texture. So if you multiply, anywhere you have black, you will have 0. So multiplying any black from here with any black from here will make sure that you keep the blacks, and multiplying by 1 is gonna give you the white, and the result is gonna be getting the contour, because again, this is a slightly smaller version of this texture, as you can see, and this is an inverted version of this texture, and this one is cutting into this one, and wherever this one has black or this one has black, we will have in the end black, and anything else will be kept. So this being a little bit larger and this being a little bit smaller, we will basically get the contour of this. That we used in 2 places. One was to mask the emission selector, and the other one was to do something else here. I'm going to show you later on. For the continents, we used this mixing of colors here, and this is going to something else, but let's look at the colors here. We get this color coming here, so now we have the colors of the points here, and then we mix them with the continents and we get this result. And as a mask, we use this point of contact mask that is taking these points from here with these points from here, and it's building this basically. And this mask makes sure that we select where is black, we will have the continents, where is white, we will have the points color. So this is how the points colors were mixed, as you can see here. And then on top of that, I use this hue saturation node to intensify the glow color, to make the points, emissive points, glow. And again, I use this mask to make sure that this effect, it's restricted only to the lights, and the continents just stay like this, faded. For the glow, we have, of course, the color and the strength, and the way they are mixed. We have this output from here, the contour of the continents coming in here, and this is the control from them. We can multiply to make the contour to glow more, And then we used this as a general glow control for the continents. So by using this mask here, we basically make sure that the base that is added on top makes that everything has this 0.5 value. Of course, then taking this value from here, the contour, and these basic values for the points and the base will give us this result. So the contours will glow more, the points will glow some, and the base for the continents and the sea will just have this strength control. So then we did a general strength control. As you can see here, we have this value that you can increase to make the points glow even more. And on top, this was added on top of everything else that we have here. So if we want to make the points glow higher, we can play with this value. That was all passed through this emission shader. What else I did on top? Let's look at this. We created a mask for the continents and points of contact. So we have these points of contact that we created here, and this is the mask of the continents. So I added those together, and that gave me a mask that we could use further down the line here when we mix some elements. Let's see what else we have here. We will move on later on to see how this mask was used. I also use this texture coordinate with the same setup, that is making sure that everything rotates with the geometry nodes to add this Voronoi texture. This Voronoi texture is responsible for creating a very interesting pattern that you can see here. This pattern here for the sea, and another one for the continents, that was used to add some transparency, because this shader, if we go to its option, uses alpha hashed. You have to activate it here in the property material for this to work. So this is basically a transparency mask added for the shader, as you can see here. And that was used to punch through the mesh and let the particles inside show through. So this transparent mesh was added in along with this emission shader, that is the glow, to get something like this. This is the base for the sea, basically, the sea between the continents. So after doing all that, we kind of had to add something to control the transparency of all the elements. So we added for the continents transparency of this Voronoi mask that you see here. So we got a mixing of transparency. As you can see here, we have the continents and the points of contact here. There is something else that I haven't showed you. I added again the same setup for texture to make things move together, and another Voronoi texture to add some lights to the continents. I got these points that you see here, and all these points were added here. We have this emission shader that is combined with the continents and points of contact. So basically the output from here, everything we did for the color and the glow. And on top of that, we added this emission that is using this mask. So where we have black, we see this output. And where we have white, we see the other output. So we get this result, as you can see here, where we get this glowing lights on top of the continents. And this entire setup was used, like I said here, to add transparency based on this Voronoi mask and get this result here. So basically now we can see the points inside of the mesh, and we can see in the continents a little bit of the points inside of the mesh. And then I played a little more with this. I added a see-through control to decide how the full hologram is being seen. And this is done here. We have this transparent control and this map range that goes to this mix of elements. So we have the sea and we have the continents, and when we mix them, and we end up with this result by using this mask. So we mix the elements here, and then using this general control, we can control the transparency of the hologram by taking this mixing of all the elements and adding the see-through effect, meaning another transparent shader, and we get this result here, because this factor is making sure that we have a control for the transparency, as you can see here, fully transparent, and the previous value that we had here. Everything is connected with the attribute that we took from geometry nodes, the reveal effect, and that's basically this value from here that is outputted inside of geometry nodes here. So we get this value. So that means that when we reveal the hologram, it also controls the transparency. And as I'm going to show you later, it controls also the world shader. But this is what controls the transparency of all the elements that we build. Again, we have the sea, we have the continents, and we use point of contact as a mask to mix those. We get these values of color and emission. Then we add the transparency controls on top of that. And on top of all of that, we get this glitch effect. Also, you can get in the file gumroad this effect that it's outputting a mask that looks like this. At a certain point, you have this line going up and down, and at some point, they have a glitch, as you can see here, this glitch, and then they go back. And you can use this to control the parameters of this, to control when you how long you want this glitch cycle to last, how fast you want to go for the movement speed, how fast you want the glitch to be, the intensity of the glitch, meaning how much these lines curve like this, the deformation, and a bunch of other parameters. And all of this, of course, a minimum and maximum transparency. All of this is mixed on top of everything we have here to make parts of the hologram be even more transparent, as you can see here. This is more transparent than this part here. This is the glitch effect. If I go inside of this node, we have this setup. Let me make it full screen so you can see it. We have the frame that it's controlling the range we want to use. For the frame range, we have this modulo number. So this is deciding how many frames the entire thing lasts. We have this module here that controls how much percent-wise we use for the actual glitch when the lines get distorted. And this logic checks out if it's time to trigger the glitch by checking out if the frame which we are is the one we calculated here. It's time for the glitch. And then by multiplying this condition with the frame, we decide if the frame should stay put or it should trigger the glitch here. And in order to make everything go back and forth for the glitch, we use this ping pong number in the scale of 0 to 1 that we remap by the intensity we want. And this was used for the distortion of this wave texture inside. Everything is based on the object coordinates, so the glitch stays on the object. The other things that you see here is the exposed values of the wave texture, so you can control them from outside, and this is just to control the transparency by remapping the output of 0 to 1 to whatever you want to decide just how transparent this glitch is. The movement on the vertical is controlled by this multiplication of the movement speed that is output outside with the frame. So this is what controls the vertical movement by playing with the phase offset of the wave texture. So this is how the setup is looking. Anyway, if you have problem with understanding this, post in the comments and I will try to explain it better. Now I'm trying to make this video shorter if possible. Going back to this setup, we have this rim emission. If we activate the final mix shader, we have this rim emission that is given by using the Fresnel. I played a little with the index of refraction. I passed it through a color ramp that I modified. So we have this maximum value here, and minimum is 0. And this is used as the factor mixing between everything we had before and this emission shader that has this purple color. So by adding just a little bit of this one, we get this nice glow on the shader. So again, as a short recap, we passed attributes from the geometry nodes for the point of contacts and also for these tracers. We did a bunch of stuff with color ramps on it to restrict the range of the points, to give them a certain shape, and then we created from all of that stuff, we created this black and white mask that we used to mix the colors of the points and also the colors of the continents that we created. And of course, we controlled also the strength emission using the same map here. We added some setup to put some continent lights on everything. This setup was this, creating a black and white mask for an emission shader, and we mix it with what we did previously. We also created this Voronoi paste mask to give it like a digital look, and we use that to affect the transparency of everything we mixed here in the shader here, where we mixed all the elements. We use this transparency to mix for the sea, and also we use that transparency to mix with the continents, but with different values. That's why we have different color ramps. So using it here, and then using it here, we added transparency, and that transparency was mixed here. On top of that, we added a see-through control by adding another transparency shader that is controlled. The general intensity is controlled manually from this control, and procedurally by the geometry nodes. On top of all of that, we created this glitch effect setup that is adding another layer of transparency modulation, creating this effect that has some transparency bars going down, and every once in a while having like a spike on them. And on top of everything else, we added another emission glow using a mask built with Fresnel to get this edge glow effect. Phew, this is a complex shader, so it took a lot of explaining, but I think it's time to look a little bit on the emission shaders. They are also kind of interesting. We have the flight lines material, so if we look at those, again we see this glitch effect was used, basically the same values to transfer the transparency here. So again, pressing the N and looking at the options here, we have alpha hashed for this one. So we have an emission shader. We are talking about the lines here, the blue ones. So we have this emission shader that has some transparency added to it manually here. Then a procedural transparency to sync with the glitch effect here, and that's gonna give us first this result and then this result here. For the motivation particles, the ones on the bottom, we have again an emission shader, no glitch effect on it. We just mix a transparent shader with emission shader, and again alpha hashed for transparency. So we get this effect for the particles that we see here down. The next shader, flight line tracer, the red lines here. If we look at them, we use the glitch effect on top of mixing an emission shader with some transparency to get this effect. Again, alpha hashed, and then on top of everything, we added this glitch effect that gives this gradient, as you can see. That is also in sync with the everything else. Although you can control and change the values if you would like to. The inner particles of the globe, again an emission shader, transparent shader, they are mixed and we get this result. So pretty basic stuff. The world shader now, let's look at the world shader. What I did here for the world shader, I was using this HDRI image. You will find the link in the description. It's from Polyheaven, and this is a great resource. So, generated mapping. I put this mapping node here to align the texture, so we get the globe in this arena, and having this interesting element in the behind that helps us realize that we are using a transparent shader. Without it, it will be kind of tough to see what's going on. And the strength is controlled, like I said, from this controller here. But one mention here, this slider, you can't use an attribute for it because this is the world shader. An attribute is interpreted in the context of the geometry. So I had to use a driver, and the way to do this, right click on the control, copy as new driver, put a input value node, then paste, right click and paste as driver. So let me do copy as new driver, right click here, paste driver, and now we have this control here that it's working in conjunction with our setup, as you can see here. This is how you can add it. And then I decided on the values I want for the strength, and when I want to start the strength here, as you can see, I decided to keep it black until this value, and then make sure that the final value doesn't exceed this 0.03 range. So this is it for the world shader. This was also used, I used the light path with camera array to make sure that we get this shader only for the camera. For lights and reflection, I wanted to use a black shader to make sure that I don't get any weird reflections on our object, on the non-transparent parts or stuff like that. Phew, what else? As you can see, we have no camera, no lights in this, so that makes this a fast to render scene. And for the camera, just default and nothing else. And this is it. We came to the end of this project. It was a really fun project for me to make. I enjoyed it a lot. And again, for those of you that don't know, this was done as a request from a long-time viewer on the channel, Roman. So this is the final part of this project. But I'm gonna make another series treating another thing. He asked about flight paths, and I thought about two methods. One was to do these kind of things that just start on the surface of the planet, and the other thing that I'm planning to do is orbiting around and at different orbits, but I'm gonna make it a lot more interesting. Hopefully next week I will have time to finish that project, and I'm gonna post it, and I hope you will like it. Until then, if you find the content on this channel valuable, you can help it grow by subscribing, commenting on the videos, liking the videos. That's all things that help this channel. And of course, if you want to support what I do here to help me keep doing it and also get something cool in return, you can download, you can purchase the project file from Gumroad. So thank you very much to all of you that have already done that. I hope you will enjoy the project and you will do cool stuff with it. And until the next video, I hope you found this information useful. Remember, you can post your comments, you can post your question. I will try to get to them and answer to the best of my abilities to help you. And in the end of this series, thank you for watching. Have a nice day and happy